Hello, welcome back to my channel, Biblical Validity, where we take a look at how science and logic and history all provide a lot of evidence for the validity or the um, reliability of the Bible. And so this starts the 6 days of creation, a series I'm doing. I think I had a introductory video I did a little while back, and this morning I recorded one on the first two verses of the Bible called In the Beginning. And so it'd be good to watch that. And that's interesting in its own right, those first two verses. and and the first two verses is really before God starts saying, "Let there be something." Let there be light, let there be sun and moon, and all that business. And in other words, He's created in the beginning. He created the um, space, volume. He created matter, and he created, most likely, Einstein's E equals mc squared, so that matter and energy are have an equivalence to one another. One converts to the other, or can, and also the time needs time. All right, so now he's ready to go, and all right. So my goal in this is to and I know these are kind of nerdy videos, many of them are at least, but to show you how intricate each day was, how complicated it was, each day of creation, and what God thought about in designing all this. And this universe really shows, everywhere you look, the universe shows design, evidence of design, an intellect that designed it. And and some scientific materialists, naturalists, and atheists, they want to deny all that, and that's their right, and they can make their arguments. But the universe has a tremendous amount of design to it, and to me, it's so meticulous what God did that it really points to a personal God, personally involved in our lives. I think some people believe that, well, if there was a God, he just created all this mess and let billions of years go by, just see what would happen and let evolution take its run its course. And no, I don't think so. When you start thinking about all the intricacies of creation, how finely tuned it is, I'm not sure how you can really come to that conclusion that it's just God just let it turn it loose and let randomness take over. All right. Well, anyway, I'll start to make my case with day one, and I hope you enjoy this and learn a lot. I've learned a lot trying to prepare these types of videos. I've been coming up to speed on the science, and it's quite a chore. Anyway, I'm coming to you, as you can see, I'm coming to you from the ocean. Sunset. It's almost sunset, and but the waves aren't moving, are they? Okay, so that was actually a sunset at Clearwater Beach, Clearwater, Florida, a couple years ago, I think, and that was where I grew up. And but actually, I'm about 1,000 miles away in my cabin doing this video, and I thought, well, I'll make this a nice background because I think the wall behind me gets a little boring. And well, anyway, so let there be light, and there's light, sun. Except God didn't create the sun and the moon and the stars until the fourth day. So I'll just let it go at that. And but there's something really interesting about sunsets, by the way. So I got to throw this in because I love trivia and I love the wonders of creation. And there is a rare event. Most people probably have never heard of it, called the green flash. All right, now you notice this is sunset and the sky is turning orange. The sun is turning an orange color. It gets to the point where it's getting close to the horizon. You can actually look at it directly without harming your eyes. And and the sun actually sets from start to finish. When it starts touching the horizon until it winks out, it's about 2 minutes. It's 2 minutes, and or half the diameter, the radius of the sun moves that far in 1 minute. Okay, well, the reason the sky is turning orange is because the light is shining through more of the atmosphere. More of the atmosphere filters out more of the, I think it's filtering out the blue light. And then, so what you see is orange. And, but there comes a moment, if you are lucky enough to watch a sunset, and Probably being at a beach is the easiest way to see this, where there are absolutely no clouds between you and the sun. And that last second, literally that last second before the sun goes below the horizon, under the right conditions, the sun will turn green. You ever seen a green sun? I have. Once I have seen that. It's called the green flash. If you're interested, you could look it up. You could go on YouTube and probably find a couple of videos of the green flash. And it's I think a pretty rare event because the conditions have to be darn near perfect. And I was lucky enough to be at the beach for one of those, and I hope to see it again. And so anyway, just another great thing about the beauty of our world. All right. Well, anyway, let's get into it here. The 6 days of creation, day one. So, and I mentioned that the first two verses are discussed in my video in the beginning. And so I just leave it at that. Let's jump into verses 3 through 5. And God said, "Let there be light," and there was light. God saw that the light was good, and he separated the light from the darkness. God called the light day, and the darkness he called night. And there was evening, and there was morning, the first day. There you go. Okay. A lot of people, including me, for many years of my life, when I didn't believe any of this stuff, I didn't believe the literal 6 day creation from the Bible. I was willing to admit that, well, maybe each day represents millions of years. No, because if that was true, it means God created things sort of out of order. Okay. And we had the plants on day 2, but no sun until day 4. And if those are spaced apart by millions of years, those plants would have been dead a long time ago. So the the Hebrew word, ancient Hebrew word used here is I believe it's yom, Y-O-M. And it literally means, in the context of how it's always used in Genesis, it means a 24-hour day, literally 24 hours. God did this. And I think that's hard for a lot of people to wrap their heads around. Like, God did all this in 6 days. How is that possible? That's why we call him God. Okay. And so God's an infinite being. We don't really understand him as well, not as well as we'd like to. And but he created everything. And why couldn't he have done this in 6 days? Besides, God exists outside of time. He had to create time for our physical universe, and which tells us that God exists outside of time, and maybe there is no time in that side. Some say that God measures time by events, not by days, weeks, and years. Anyway, yeah, it's hard for scientists to wrap their heads around this. It just doesn't work this way. These processes take millions of years. Okay, well, anyway, so what can we get into this? It really didn't look like God did much the first day. He said, "Let there be light." He flipped the switch, and on comes the light. And so I think we tend to gloss over that as, well, not okay, great. Well, let's explore that concept of light. And it's a big one. It is humongous, the concept of light and all that implies. And so, all right, so we get into this. I'll try to make it as simple as I can. That way, I might be able to understand it, and hopefully you will. Unless you're an expert in this field, in which case, if I make mistakes, please let me know. Send comments in. And I appreciate that. If you catch me in science mistakes, I wouldn't be surprised if I made some. A friend of mine pointed out, I think I misused a word from biology in another video, and I'll need to correct that someday. So anyway, I appreciate those corrections, and if they're major, I'll make sure it's really gets corrected on these videos somehow. I'll figure that out. Okay, so let's explore the concept of light. Light comes from electromagnetic radiation, which is the interaction of electricity and magnetism. So we all know what those are separately. Electricity, of course, goes through the wires, powers our appliances and all sorts of things. Magnetism, of course, we know what magnets are like. The interaction of electricity and magnetism produces electromagnetic radiation, and from that, light comes out of that interaction. Right now, we only see a kind of a narrow band of that electromagnetic radiation. So the light we see is a narrow band of frequencies of such radiation that our eyes detect and that our brains interpret. All right. So frequency is, think of a wave pattern, and the number of times it goes up and down per second, per minute, however, how fast it goes up and down is known as frequency. And in sound, a low frequency is spread out, whereas a high frequency, a high pitch, is very fast frequency. Well, when it comes to light, a high frequency tends toward the blue violet end of the spectrum, and go above that you have ultraviolet. That's high energy light. And lower energy light trends toward the red spectrum, lower frequency, and below red is infrared. All right, so humans, we only see from red up to violet, or what's that last one called? Seven colors of the rainbow. Indigo? Indigo is kind of a really dark purple, I guess. That's what we can see. I think there's some animals can see a little bit beyond that. For example, my uh, when I had a dog, the vet I took my dog to, he told me about it. He told me about an experiment where he had picked a tick off a dog. He put it on the counter, held his hand there, and every time he did this, the tick managed to spot his hand and jump onto it, because the tick could see apparently in the uh, infrared range, which it can use to detect heat. So you can detect heat in the very low frequency range. Very interesting. So I imagine some animals have a little bit different spectrum that they can see. All right. Well, all right. So, but electromagnetic radiation is also like radio waves, TV waves, microwaves, X-rays, things like that. And we only spot just a narrow band of the full spectrum electromagnetic radiation. We can only detect with our eyes kind of a small band. It's kind of like where our radio's tuned to in terms of eyesight. All right, so well, first let's see how matter is put together. Because light radiates from matter as a form of energy. And so we all learned in school that atoms are made of electrons, protons, and neutrons. And by the way, I think electrons were discovered in the 1890s. I'm kind of winging it here. Protons, maybe around 1910, give or take a few years. Protons and neutrons were tough because carrying no electrical charge, they're a little harder to find those, but they were detected in the early 1930s, maybe 1934. I forgot exactly what year. And so and we had this picture, at least I did, and many of us grew up in school having this picture of the atom as sort of a little miniature solar system. We had a cluster of protons and neutrons forming the core of the nucleus, and then you had electrons orbiting around. I believe now they're not so sure about those electrons orbiting. They almost sometimes they represent them as a cloud of energy, and there are different shells for electrons, and shell one, shell two, shell three, shell four, and it's actually kind of related to how we hear musical tones. Oddly enough, I can make that connection in a kind of strange way. Anyway, it's pretty neat stuff. Now we know that electrons carry a negative electrical charge, and protons carry a positive electrical charge. And so there are. So we talked about electromagnetism um, is a force. Now, before that, they were considered two separate forces, and it was who was it? Around 1860, James Clerk Maxwell, a Scottish physicist, who found that electricity and magnetism have a sort of an equivalence together, and you can go from one to the other actually fairly readily. And we do that with like a fan. Electricity goes into a fan, and the electricity whips around some coils and creates a magnetic field which drives the fan blades. Whereas a generator, um, let's see, electricity, magnetism. Generator uses electricity to generate, uses a magnetism to generate electricity, and in the reverse direction. So we can go back and forth between electricity and magnetism in various ways. Very useful to our world. Thank you, Lord. Okay, for making it so. The and atoms are mostly space. Like you're looking at a video of me. If I was looking at you, we would be looking at mostly just emptiness. And I think I mean, I guess it's quite exactly right, but this is going to be very close. If you wanted to represent an atom, and if you're in a big football stadium, and on the 50-yard line is the nucleus of the atom, and let's say it's the size of, I can't remember if it's the size of a pea or a marble, but small. That's the core of an atom. And then around the outer edges of the stadium, up up at the top, whizzing around are the electrons, very far apart. And so it's a lot of airspace there, or vacuum space, however you want to call that. And amazing. So and some other things about this, I'm hitting my palms together like this. They're really not touching each other. Okay, now they're crazy. They are touching each other. Well, yeah, it sure looks like it. But I cannot touch with my hand another object directly. In other words, the atoms do not touch atoms. What we're getting is the repulsion of magnetic force. Electromagnetic forces are repelling, and although they're just extremely close, where it's actually that electromagnetic repulsion that that we're actually feeling, that we actually feel. Anyway, it's kind of mind-boggling to think about all this. We're just the stuff that we're made of, that got compacted into a little tiny particle that might be all the stuff in our body. We have so much vacuum space in between electrons and the nuclei. All right, so now there are three other forces. Gravity, of course, is the one we're very familiar with. And there's also it's what's called the strong nuclear force and the weak nuclear force. And now the weak nuclear force is important to producing sunlight. All right, we'll talk about that later. Now gravity is by far the weakest of the four forces. It's far, far weaker than electromagnetism. So I think this is what I've heard a couple of times. The number 10 to the 40th comes to mind. And 10 to the 40th power would be 1 followed by 40 zeros. That's a big number. All right. That's how much stronger electromagnetism is compared to gravity, which is why magnets pick things up very easily. They don't even notice gravity. And so the gravity is the weakest of the four forces. And electromagnetism is very strong. And by the way, just a footnote, gravity is not at present understood at the atomic level. And sometimes that's called the quantum level, or in quantum physics. They're still trying to figure out, does gravity play a role at that atomic level? And I think the answer right now is that no one knows for sure. It's a great quest to try to figure that out. And so it's being that gravity is so incredibly weak compared to the other forces, it probably goes a long way in explaining why we can't even detect it at the atomic level. All right, the strong nuclear force, to elaborate, the strong nuclear force keeps the nucleus of each atom together. So you have these protons, and in most atoms you have neutrons. No, hydrogen does not have a neutron, and does helium have neutrons? Probably not. Maybe lithium gets them. But anyway, protons, because they're all positively charged, they want to repel each other. And so they have to be held together. God had to think of this. And so he created the strong nuclear force to hold the nucleus together. And so when it really wants to just fly apart, okay. And then the weak nuclear force is related to how atoms can split apart or fuse together. I don't understand that part terribly well. I think when I get to day 4, I'll try to come up more to speed. I do have an idea of how fusion in stars produces starlight, and that's the related to the weak nuclear force. And so, and it's very interesting. There are still people alive in this world who were alive when no one understood why the sun shined or why the stars shined. It wasn't until 1938 that someone figured all that out. It's very interesting. All right, so the way God designed matter allows for all kinds of things, including light, and allows for matter, allows for electricity to flow and power our appliances and do all kinds of nice things. Um, it allows for magnetism, can be very useful. Electromagnetism, we can broadcast radio signals, we can build microwave ovens and all kinds of things. So God designed all this stuff. It was incredibly useful, been very useful to us. And it's just I don't chalk that up to randomness. And now scientific materialists who don't believe there was a God had a hand in any of this stuff think this is just all random luck. All right, we just happen to live in one of those universes where everything just works. Okay, um, all right, it's they're trying to skirt the issue of that it took a supernatural being to create this universe. Matter does not come from non-matter. Life does not come from non-life. And you can go on and on. And they're still wrestling with that. Like, well, there's got to be a way to explain this universe without involving God of some way. All right. Now, depending on who you listen to, there are 94 or 98 naturally occurring chemical elements found on Earth. That's the number I've tracked down. And so there's about, you've probably seen the periodic table, which lists all the elements. And I think currently the table goes up to element 118. Some of the ones at the very high end are artificial elements that we can only create in labs. They're not found in nature. There is one element. It might be americium. I could be wrong though. It might be something else. There's one element that's so scarce that's estimated there's only about maybe 20 atoms on Earth at any given time, and because they appear when another element will split, but they last a very short time, and then they split into something else, and so they that's the way that goes. So we'll never find that in nature, but they've created that element in a lab, for a short duration of time. All right, so um, now atoms can combine with other atoms by connecting to their outer shell of electrons. And so you think about water is we call it H2O. There are two hydrogen atoms and one oxygen atom. And if you get hydrogen um, and light it in the presence of oxygen, it's going to that fire or explosion is going to cause these atoms to combine together into water. The most part, we have two atoms of hydrogen combined with one atom of oxygen, and the electrical shells um, are is so well disposed that combines together very easily. All right, so I'm not a great expert on that chemistry, but it's very interesting how that works. I think that we have the ability to create just almost an unlimited supply of molecules. Molecules are combinations of atoms. So we get all kinds of different chemicals, molecules, and that we can create and use very useful in our lives. So we need that. And these molecules show up everywhere in nature. Lots of places in nature have molecules, particularly water and carbon, carbon mixed with other things, hydrocarbons. Organic chemicals are, the building blocks of life. And for the most part, we can't even create those in a laboratory, organic chemicals. And two guys managed to create a few atoms of what's the name of it? Amino acids in 1952. And but they're not the amino acids that we find in life in bodies, but they're amino acids. They're kind of hydrocarbon, I guess, or organic chemicals. And but science hasn't had really any luck since then creating these really complicated chains of hydrocarbons and things that make up organic chemicals, the chemicals of life. And so the argument that life could arise by sheer chances is just totally out of the water. It's just no chance. And we'll do a video on that someday. And I'll point you to a world-class expert who will tell you in great detail why that's not possible. All right, so let's see here. Fire is one source of light, mostly when carbon and oxygen combine at high temperatures to also produce heat and carbon dioxide. Now, other things burn. You know, there's lots of things will burn in the presence of oxygen and a lot of heat. And but we're probably mostly, used to wood fires, and which is very useful for this world. Um, so look at this. Fire from wood gives us heat for warmth and cooking, along with light. Wow. Okay. So uh, God, planted all these trees. We can burn them. We can cook things with them. We can keep warm. We can make light with it. And now, where does the light come from? The when wood burns or something burns, all that heat is that energy is causing electrons to expand away from their nuclei into higher shells. And then as soon as it starts to cool slightly, they jump back down into their more original, closer shells where they really belong. And that process of cooling creates the light because there's a loss of energy. Energy causes electrons to move away from the nucleus and cooling down. When they come back together, the energy is being lost, but there's conservation of energy. Where does that energy go? Well, photons are released, and photons are little packets of light, and that's where light comes from that. At least that's my understanding of that. Anyway, so a little more elaboration here. Energy can temporarily cause electrons to move outwards to more distant shells around the atom. When they collapse back to their standard configuration, the energy lost to the atom can be transformed into photons of light. And I'll talk more about photons in a moment. For example, this is what makes fluorescent and neon lights work. A fluorescent light is a tube with a gas in it, and electricity runs through that tube. And now it takes AC current, alternating current. So alternating current goes from a positive charge to negative charge, positive, negative, positive, negative. 60 times per second in the United States. It might be a little different in European countries or other countries. But in the United States, it's 60 hertz, they say. That's the frequency of alternating current. And so you have a maximum electrical charge at the top of these little wave patterns called sine waves. And so that maximum energy forces the atoms away from their nucleus. And when it comes back down, in the middle there, it's that energy is lost, and the electrons snap back extremely rapidly, and the energy is lost, and photons are emitted, and then back to the bottom is more energy, except this time it's a negative charge, and that happens quite a bit. So fluorescent lights flicker really fast, too fast for our brains to pick up. So they actually are flickering lights, but too fast for our brains to perceive. And so I always thought that was neat when I learned that. That's why that stuff works. Wow. Um, Light from our sun or starlight in general is produced when atoms in the core fuse together. So I'm going to talk more about that in the day 4 video. And when God created the sun, the moon, and he also created the stars. The greatest understatement in history. He also created the stars. Trillions and trillions and trillions of them. Okay. All in one day. Wow. Okay. Remember, God lives outside of time. He doesn't worry about time. Electromagnetism combines electricity and magnetism to produce oscillations or vibrations in waveforms that move at the speed of light. This electromagnetic radiation also consists of particles called photons, each of which carry a packet of energy. So actually, light is both a waveform and a photon, and particle form as far as photons. Light was discovered to be a waveform around 1800. Someone passed light, candlelight probably, through 2 slits, and what's shown against the wall was an interference pattern. If you look up the double slit experiments, you'll find out everything you want to know about that. And so it really demonstrated that light is a wave pattern. It has frequency. And then in the late 1800s, the photoelectric effect was discovered. There are certain materials, when light strikes the material, it creates an electrical charge. And how did that work? And so scientists were scratching their heads trying to figure that out. And along comes Einstein. Yeah, that guy again. Einstein, unknown guy working in a patent office in Switzerland, wrote 5 papers that year in 1905, and all of which really deserved the Nobel Prize. Incredible work. Einstein said, "Well, okay, I think I know what happens. Light is both a wave pattern and a photon or a particle. It's both particle and waveform." And and then experimentally, that just seems to bear out quite extremely well. So now let me go back. I think in the 1920s, is this guy French? It sounds like he's French. You look at his name, it looks like de Broglie, but I think it might be pronounced de Broglie. So apologies if I'm not pronouncing that right. De Broglie. I think I heard he wrote probably one of the shortest dissertations in history, about a 7-page dissertation, proving that everything is made of waveform and particles, including us. We're both waveform and particle. The wave frequency is to be so astronomically high you can never measure it, but we're a waveform. How about that? But we see ourselves as a particle form. All right. Anyway, I think that's very interesting. Photons are massless. And what massless means, if you don't know your physics from that, this means that they carry no weight when gravitational force is present, or gravitational. I should say gravitational acceleration. My apologies, physicists. Would that be better? Gravitational acceleration, because mass times acceleration is force. All right. So anyway, gravitational acceleration. I should scratch that word out, but I don't feel like redoing all this video. Anyway. So mass is like how much stuff is there, and it takes on weight when you're in a gravitational field. The acceleration of gravity um, gives it a force, gravitational force. How's that? Anyway, photons are massless. And they're so far they're the only confirmed massless particles. Now there may be more. There's some hypothesized, and but they haven't been verified yet through experimentation. So there might be another particle or type of particle or two out there that physicists is trying to locate that may be massless. But that's my understanding, and maybe there is. Anyway, photons are never at rest. They always move at the speed of light. Okay. Now, you can temper that argument. Light moves at a little bit different speed through, uh, say, water, through air, through anything that light can move through. So it changes slightly, and it can. In a vacuum is usually what we think of as the speed of light in a vacuum is the maximum speed. And if you don't know it, it's around 186,282 miles per second. So if you could make a light beam wrap around the Earth, circle the Earth, it would go around the Earth about 7 times every second. And in the kilometer world, that's 300,000 kilometers per second. Very fast, okay? And there's all kinds of neat stuff with Einstein's relativity, which I could actually show you how those calculations come up. That the math is not hard, but very interesting aspects there that Einstein, that guy again, came up with, and has been verified experimentally. And by the way, let me just say something about Einstein. The reason he's a household name is because his major theories were verified through experimentation. Okay, they are observational science or experimental science. They can be verified. And so that's why Einstein is a big name, because his stuff can be shown to be true through repeated experimentation. And so they're not just theories that we theorize and can't prove. All right, now where was I? Yeah, photons move at the speed of light. There's a very interesting problem with the speed of light, by the way, which I only heard about this a few months ago. But Einstein and others in his era were thinking about the speed of light, and they realized that it's not possible that anybody can figure out. It's not possible to measure the speed of light in one direction. Okay, we can only measure the speed of light going one direction and returning, like bouncing back off a mirror, for example. And I think it's called the Einstein synchronization problem. And it may have a very interesting application to the size of our universe. I'll talk about that someday. There is a noted young Earth creationist astrophysicist. He's very good. He has an interesting theory about the speed of light. But anyway, let's leave that alone for now. All right, so the light we see is a narrow band of electromagnetic radiation. I kind of mentioned that. Electromagnetic radiation also takes the form of radio waves, microwaves, X-rays, and probably some others that I didn't run into. Okay, so a whole big band of electromagnetic radiation, and and all that stuff has been useful to us. Radio waves, microwaves, X-rays, been very useful for us. When electromagnetic radiation in the spectrum of light strikes our retinas, which are tuned to react to the colors of light, our retinas send nerve pulses through our optic nerves to our brain, which then interprets what we see. Um, the eyes are incredible. Incredible. How in the world could we have gotten these eyes through the processes of random evolution? Um, some people believe that's possible. Okay, it's just incredible. So light enters the cornea, passes through the lens, which focuses the light coming in onto the back of our eyes, where the retina is, and the retina are the rods and cones, um, which react to the light coming in, and it's the photons striking the rods and the cones, which is a little bit like the photoelectric effect. Remember where light strikes a certain kind of surface, it creates an electrical charge. It's kind of like that. It seems to be the photons hit those rods and cones, and a photon can actually destroy what I read is they can actually destroy those cells, and but the body replaces them very quickly, and I can really notice it if you stare at a very bright light bulb or something like that, light source for a few seconds, then close your eyes, and you see this afterglow. Um, that I'm thinking that afterglow is because your eye is repairing itself because it got hit by too many photons. All right, so it takes a few seconds to maybe a minute to lose that afterglow, and everything's repaired again. And if you were to stare at the sun in broad daylight, for too long, you're gonna go blind because now the damage is too far gone. Anyway, so yeah, photons go through there. Pretty amazing. And um, there you go. So our brains give us the capability of perceiving a focused image with all the possible visual colors. All right, and I just remind you, why am I looking at all this? Why are we talking? Why am I talking about all this stuff? Uh, when God created light, He created all these other things I'm talking about, and more, I'm sure. Maybe I'm only scratching the surface. Maybe I'm just hitting the big stuff. But just the act of creation of life was not trivial at all. It's incredible. He made it's vital to having matter and energy and all that stuff and for life in itself. Our brains give us the capability. Oh yeah, I forgot to mention. What if fire did not emit light? Okay, we'd be in big trouble if fire didn't emit light, right? Because your woods could be, you could be a forest fire a couple hundred yards away. You wouldn't even know about it, and before long, your house is burnt down. You'll feel the heat, but you won't see it coming. And so God not only gave the fire as a gift for seeing things, He also for warning us of danger from big fires. All right, let me go back to the slideshow. Our brains give us the capability of perceiving a focus image with all the possible visible colors. The colors we see are specific wavelengths reflected from surfaces. This is my understanding. I hope it's correct. If nothing is reflected, that item it looks black. If all the light's reflected, then that item looks white. And there you go. And what about colors? Well, most things we see, anything that's not white or black, absorb most colors and reflect a particular color. Like that orange sunset behind me. Where does the orange come from? The the colors of the full spectrum of light hitting that sky get absorbed, but what gets bounced back are frequencies in the range of orange. So we see orange. Okay, so the orange is a reflected color. So it's yet another wonderful miracle of God that most things we see are colorful, and this allows for a lot of beauty, incredible amount of beauty, and in our world. And the people that believe that well, life exists, it's just a randomness, and everything evolved over millions and millions of years. The first single cell organisms appeared on Earth maybe 3 billion years ago, and about 1 billion years ago they started to evolve into multicellular organisms, and eventually you get the humans and and whatnot. The but what would explain the beauty that we see? Because you would think that if evolution is what drives everything in life, then it can only be focused on survival and gaining advantage. And what advantages are in pretty flowers and pretty sunsets and things like that. We see beauty all over the place. This is God's engineering, and it's incredible, incredible. Okay, so how could an impersonal, totally natural universe end up with such beauty that we can see? Yeah, how could that happen? Pretty amazing. Okay, so let's recap what God did on the first day of creation. I'll try to wrap this up and not ramble too much longer here. God designed the universe with the four fundamental forces, which includes the electromagnetic force. And electromagnetic force allows, among other things, allows matter and light to exist. Okay, and these are tuned precisely in terms of their relative strengths. Otherwise, life would be impossible. And I'm going to go into that another day, perhaps in another video series about the fine-tuning argument and how the constants of nature, the numbers of nature, have to be very precise in most cases, or otherwise we wouldn't have life as we know it. It might not be life at all. So we'll get into that another day. The electromagnetic force is vital to holding atoms together, allowing atoms to combine into molecules. For electricity and radio waves we use, along with light itself. The wave frequencies and the light particles are both vital for the transmission of light and our being able to see. So here you go. So the beauty of the colors we see in our world is difficult to resolve with the remorseless random theories behind evolutionary theories. All right, so so we'll wrap it up. You might say that God speaking light into existence is greatly underestimated as to its ability to allow for the universe we live in. God, of course, had to decide all this was going to work. He took meticulous care in designing the creation of light and all that entails. Okay, and it just builds better as we go through the days of creation. The amazing things that God created. It seems kind of simple, and we read through it quickly when we read Genesis, but I'm thinking, wow, God, think of what God came up with to make all this work. All right, so I hope you learned a lot and got a lot out of that. Hope you enjoyed day one of creation. Okay, and now we'll go on to day two next. And so I think I'm done with this video. And thank you for listening. I'm honored for you tuning into these. And I hope you get something out of them. Okay, well, time to, as I say, roll the credits. So roll credits, and we'll see you. Hope to see you soon.